Hey guys, how's it going? And today we are on leetcode with another problem that is coin change. So we are given an integer array of coins representing coins of different denominations and an integer amount representing the total amount of money. So we need to return the fewest number of coins that we need to make up that amount. And if the amount of money cannot be made by the denomination, then we need to return -1. So we are given an amount and we are given the denominations of coins. Now we need to check whether we can make up that amount with these denomination. Also, we need to use the fewest number of coins, and then we need to return how many coins we used to make up that amount. So that's our problem statement, and this is a typical dynamic programming problem, and where we break our problem into sub problems and then we solve that sub problems, and then we use the result of those sub problems to solve the larger picture. So we will use that approach, and what we will do here is we will just break up the amounts. So for amount 0, how much coins are needed to make that amount 0? For amount 1, how much coin is needed? For amount 2, how much coin is needed from the given denomination? And so on, we will solve till the amount that we are given. So this is the approach that we are going to solve, and let us start our problem. So first of all, we'll just take out length of the coins uh, here. So int n is equals to coins dot size. Then we will create a vector array of integer type. So what where we will store all the minimum number of coins needed from 0 to the given amount. So the size of this array will be amount plus 1. So let us name this array as TP itself, and then the size of this will be amount plus 1. And let us initialize all the values in this array as -1, since it's our base case. If we are not able to make it, then we have to return -1. So we'll just initialize all the uh, dp of dp array with this -1 value. The next what we are going to do here is we'll just initialize dp of 0 as 0. Because to make up a 0 amount you need 0 coins, so that's obvious. And for the uh, next amount values, we will use a loop. So for int I is equals to 0 I less, let us make it as 1, since we have already covered this case. And for I less than the given amount, so amount plus 1, and then I plus plus. So we have a loop to cover all the uh, from 0 to amount. So this loop will cover all the intermediate values. Now we will have another loop where we will traverse through each coins, and we will check whether from each of those coins can we make this amount or not, using minimum values. So for j, int j is equals to 0, and we will just traverse this list. So the size is n and j plus plus. Now here we will assign dp of I. dp of I is equals to minimum of dp of I and Now, what we are trying to do here is we are trying to check whether the current value of dp and okay, so let us not assign all the values as -1 because it will mess up with our case. So let us assign it with something more meaningful, which won't be covered in our case. So let us assign it as amount plus 1. So this is some invalid value which is greater that we have assigned to all our TP indexes. So what we will back to our case. So for each value for each amount, we will check whether it's the current value inside it, and if we use a coin, if we use the coin that is in the index j. So first is 0. So if we use the coin that is in index 0, that is 1, then it will be one coin plus whatever the coin that is used to make that is used to make the amount I minus this amount. So I minus coins of j. So coins of j holds value 1. So if we use this coin, then we will just decrease this amount from our amount that we are currently having, which is I. So whatever minimum number of coins that are used to make the amount I minus the denomination of the coin that we are currently using, plus 1 for because we are using the current coin, and the other case is just the value that is stored inside the uh, of the dp vector. So we'll compare these two values, and we will take out the minimum value, and then we will assign it to our dp of I. So the I is the amount, and to make that amount, this is the minimum number of coins that are needed. So it is covered, and at the end we'll just return dp dp of amount if it is greater than our amount. I mean, if dp of amount is equals to amount plus 1, then we couldn't find any minimum number of coins. So in that case, we will just return -1. And if it is not, then means we have found some minimum number of coins. So we'll just return dp of amount. So that covers our cases. Let us run the code. Okay, here it will be a code. Here we need to add a case. Why we are getting an error? Because it may happen that our I minus coins of j may become negative. So we need to add a case here that coins of j needs to be less than I. So it should be less than I. Then only we can compare the values, or else if it goes into a negative state, then we will have a trouble, which is this addition of an unsigned offset. So let us just put it inside a case and run it again. Yeah, it can be equal also because we'll take the coin 0. We can take the coin 0. 0 is an permissible index. Let us run again. Okay. So let us submit also. So this solution took 104 milliseconds.